they knew that there was certain key positions in space that when the planets or the sun or the moon transited these points, things would happen. Well, the great year of the world basically is based upon, if you'll notice that the first two cycles I talked about, diurnal and annual, are based upon motions of the Earth. The great year of the world is also based on motions of the Earth. The third motion of the Earth goes like this. The Earth is spinning around like a top. In fact, what's causing it primarily to do that is the combined gravity fields of the Earth and of the Moon and the Sun, acting on it like a flywheel, tending to pull it around, and it's doing this over a cycle of approximately, Cameron? Approximately 26,000 years. Yeah, about 26,000 years. Now, can you try to imagine if you're watching this as going around, if you're standing there at the North Pole looking straight up, what's going to be happening? What are you going to be seeing? You're going to be seeing the whole sky spinning around over your head. If you could like fast forward through 26,000 years. So if the planet, and it maintains a relatively constant tilt through that process of 23.5 degrees. 23.5 degrees out of perpendicular to its orbital plane. You see, the Earth is not straight up and down relative to its orbit plane. It's tilted over 23.5 degrees. And that orients the planet a different way to the cosmic domain. Over 26,000 years, it's spinning around like this, so that on the one hand, somebody on the North or South Pole is going to be seeing a great circle that defines a constantly changing celestial pole. You probably know that at the present, the North Celestial Pole is occupied by the pole star, Polaris as it's called, and hopefully everybody knows how to find it. Well, what would happen if you're standing on the equator during this cycle? Well, what you would be seeing is that the star patterns would, over a period of 26,000 years, they would be rising and falling over a span that covered 47 degrees. Twice 23.5, because remember, the 23.5 degree tilt. So as this spins around like this, if you're on the equator, it's a total rocking of 47 degrees. And so the sky is going to be appearing to go up and down by 47 degrees. Well, what that's doing is causing a constant change in the relationship between any given position on the surface of the Earth and the sky, and how it relates through the course of the year. Well, we've all heard of the age of Pisces and the age of Aquarius, etc., haven't we? And that we've been in the age of Pisces. What was the age before Pisces? Aries, very good. What was before Aries? Taurus. You see, now you're going backwards through the zodiac, because there's a scientific term for this motion that I just demonstrated here. It's called precession of the equinoxes. And precession implying that it's going in the opposite direction from everything else. Everything else appears to be moving from the west toward the east. The Earth spins, so it turns toward the east. It orbits, so it turns about towards the east. When we look at the planets, with the exception of retrograde motion, all of the planets in the sky are moving from west to east. The moon moves from west to east. The vernal equinox point, though, is moving from east to west. It's moving backwards from everything else. So while the sun goes forward through the signs in the course of a year, the vernal equinox is moving backwards through the signs. And we use the number that Cameron said, 26,000 years. And you know, in the circle of the zodiac, how many signs are there? 12, right? Everybody knows that. So would you take the calculator, and here's what we're going to do. We're going to actually refine that number a little bit. Most modern astronomy texts will give the rate of precessional motion as 50 seconds of arc per year. We take a circle, divided into 360 degrees. Each degree is divided into a 60th minute part called minutes, because it's a minute part. Then each of those minute parts of the degree are further subdivided into a second order of minuteness. Hence, those little increments of time we call seconds, because it's the second order of minuteness. Now, let's do this. 360 degrees times 60 minutes of arc gives us how many?
Sorry, I jumped ahead.
Jumping. Wouldn't you know, a Georgia Tech student, he's jumping ahead. 21,600. Remember this number. We're going to add it to it. We're going to get a set of numbers here in our mind that we're going to learn. We've learned 86,400 that connects with the number of seconds in a day, the number of miles in the diameter of the sun, the number of years in one of the great Vedic cycles. Now we've got a number 21,600. Okay? If you multiply that by 60, we'll see how many seconds of arc are in any given circle. A second of arc really allows us to measure small increments on a circle. So how many do we get when we... 1,296,000. Now, one of the things we're going to learn, we'll be seeing the table here in a minute. In the Vedic cycles, we find there is a Treta Yuga that comes after the Dwapara Yuga. The Dwapara Yuga had 864,000 years. The next one beyond that had 1,296,000 years. These ancient authors of the Vedas were conceiving of some grand, vast cycle that took 1,296,000 years. And interestingly, if on some level there is an orbit or a cosmic circle involved, then each year corresponds to 1 second, one small, minute second within that wheel, within that. Okay, now here's what I want you to do. You got that number, 1,296,000, right? Vernal equinox, the thing that's coming up this weekend, right? It's coming up in literally hours. Tomorrow, when the sun crosses exactly perpendicular to the equator at one moment, and from one spot on the surface of the earth at one moment, day and night will be exactly the same length as the sun stands exactly perpendicular to the equator, right? That point occupied by the sun in space, when that moment of balance happens, when that moment of cosmic balance happens, that point, it's not the sun, it's not a physical object, it's just a location in space. And that location is moving. It's moving towards the west at 50 seconds of arc per year. So now what you do with that number, 1,296,000 seconds, the whole cycle divided by 50. And there's our magic number, 25,920. And this is the number that we find embedded in all of these ancient patterns of time reckoning, the 25,920 year cycle. That 25,920 year cycle is divided up. That is the great year. And notice the graphic up here. You see what's being shown? There is a snapshot of this business that I was just talking about. You see it? That's what's being shown with that hourglass. If you carried it on through from the South Pole, you'd have the hourglass on the other side. That full cycle is what takes 25,920 years. Okay, the ancient peoples, just as we divide our year into 12 months and 4 seasons, the ancient peoples divided the great year into 4 seasons and 12 months as well. Try this. In your calculator, you still got 25,920? Divide that by 4, and we'll get the number of years in a season.